Today we're going to look, we're going to start our next unit, and we're starting with chain rule. So we're going to continue with derivatives with something called chain rule. Think about if we have a composition of functions. We have to take the derivative of what's in the inside of it. We haven't taken that into account yet. And I like to say you're working your way out to the inside. All right. So here when we have we're taking a derivative of a function within a function. What we do is we take the derivative of the function on the outside first. And then we times it by the derivative of the function on the inside. Okay, so let's play that out for a second. We're working our way from the outside in. All right, so here on the outside I have the exponent. So to find the derivative, the 3, I'm going to use the power rule. 3 comes out in front, and I keep this 3x plus 2 the same, and now I drop that by 1, and now it's 2. Now I find the derivative of the inside, and I multiply it. So the derivative of the inside is 3. So this comes out to be 9, and then 3x plus 2 squared. I'm not going to bother and simplifying that. Just leave your answer like that. Okay, so again, I'm working my way from the outside in. Look to see if there's any exponents, and I don't see any exponents. So the next thing on the outside is sine. What is the derivative of sine? Cosine. We just say cosine of 2x. All right, and what is the derivative of 2x? It's 2, so we multiply it. And if I want to clean this up, it's going to be 2 cosine of 2x. All right, moving right along. Now, this one's a little bit different, number 3 is, because look, I have an exponent. Let's deal with that exponent first. All we do is bring that exponent out in front, and that becomes cosine, and everything else stays the same. Now we work our way. Okay, now you say, what's the derivative of cosine? Don't worry about what's inside. Derivative of cosine is negative sine, and you keep the 3x plus 1 there. And now we continue to work our way inside, and we say, okay, what's the derivative of this right here, of the inside? Well, that's just 3. So now to clean it up, now be careful, there's a negative 1 right there. I can say 2 times negative 1 times 3 is negative 6. And I have the cosine of 3x plus 1. And then I have the sine of 3x plus 1. Now, I do want to recall something with you because I'm going to change this. If this was a multiple choice, they may not have that as the answer. Okay? I want you to recall earlier when I said from pre-cal, please remember and memorize things, your trig functions and such. And remember this right here. Okay? 2 cosine x sine x. I can actually change this. Like that. All right. And then if I notice, well, this right here is just this right there. Okay, just be careful because what you're going to have to do is you're going to multiply the 3x plus 1 by 2. And I end up with negative 3 sine of 6x plus 2. So this is a correct answer right here, but be careful if it's multiple choice, you could see this answer right there. All right, now let's recall. Anytime you have a radical, you want to change this first before we find the derivative to 1/2 to a rational exponent. All right, and now we're going to perform the power property. Work your way from the outside in. So on the outside, I see the exponent. So y prime, I'm going to bring down the 1/2, keep the inside the same, and you drop the exponent by 1. So 1/2 minus 1 is negative 1/2. All right, now you times it by the derivative of the inside. The derivative of the inside, we're going to say 2 times 3 is 6, so 6x, and then minus 1. That constant's 0, so I don't need to worry about that. Now, if I'm cleaning this up, you're welcome to leave the answer like that. However, if I'm cleaning this up, and again, multiple choice, they're going to simplify this. All right, put the 6x minus 1 on top. All right, the 2 can go in the denominator, and realize that this is going to go in the denominator right here, but I can change it back to a square root. All right, so that may be how the answer actually looks if it was multiple choice. But again, if you leave your answer like that, I'm fine with it. All right, but again, multiple choice, be able to pick your answer. All right, here we go, moving on. Let's look at number 5. First thing I notice is an exponent. So I'm going to bring it down, drop that by 1, so it becomes 1. But don't forget, you got to take the derivative of tan. The derivative of tan is secant squared x. All right, and there's nothing to simplify there, really. You can just leave your answer like that. All right, moving right along. Now, in a problem like this, I would make this so that the 2t minus 3 to the negative 2. You can use quotient rule, but when you have a constant up top, it's just honestly easier if you just bring that up top with it. So here we go. G prime of t. Say negative 2 times negative 7 is positive 14. Keep this the same and drop this by 1. Negative 2 minus 1 is negative 3. Now multiply it by the derivative of the inside, which is 2. So if I want to clean this up, it's going to be 28 times 2t minus 3 to the negative 3. And if you want to put that in the denominator, go right ahead, but you do not have to. All right, we're going to continue. Now, sometimes we have to apply the product rule or the quotient rule in this. Okay, in this case, you will notice that I have a function here and a function here. So, to find the derivative of this, I'm going to have to use the product rule. So I'm going to keep this one the same. Now, what you might want to do before we actually do that is change this so it is to the 1/2. All right. Okay, so I'm going to keep x squared the same. Okay, now you're going to do it times the derivative of the second part right here. Well, I'm going to have to use the chain rule there. I'm going to bring the 1/2 out and make 1 minus x squared to the negative 1/2. All right, and then times it by the inside. Well, you're doing 2 times this negative 1, so that's times negative 2x. All right, plus, all right, we keep the second one the same. And this one's a little nicer because the derivative of the first is just 2x. I'm running into number 8, but that's all right. Okay. So let's clean this up a little bit. You will notice that here the 2's cancel. Okay, this is x squared up top. This is an x up top, so that actually makes x cubed. All right, this I got the negative, so make sure it continues to be negative, and then this can actually go down low. All right, now this part plus, if I really just want to say 2x times the square root of 1 minus x squared. Now, you can get a common denominator to put this together. If it was a multiple choice problem, you do need to practice that. Okay, so let's just practice that for a second. If I wanted a common denominator, what I need is, this needs to be a square root of 1 minus x squared, so I need to multiply it top and bottom. All right, this is just negative x cubed over, and our new denominator is going to be a square root of 1 minus x squared. All right, well here I'm going to still have the 2x, but it's going to be times, when I multiply these together, the radical falls off. So this is negative x cubed plus 2x minus 2x cubed. All right, so this is negative 3x cubed plus 2x all over the square root of 1 minus x squared. So this If it's a multiple choice, that's what it's going to look like. Now they may switch the 2x and say 2x minus 3x cubed up top instead. All right. I'm okay for you to keep the one, I wrote it in green, I don't know if you can tell it's in green right here before we got the common denominator, but still remember how to get common denominators. All right, let's move on to number 8 right here. Okay, number 8 is going to be the quotient rule. Now, I'm going to go ahead and change this to x squared plus 4 to the 1/3. Yes, you can make this product rule by bringing that x squared plus 4 to the 1/3 up and making that negative, and that's perfectly fine. All right, but I'm going to remind us of the quotient rule. Remember, we do for the derivative, we do the low times the derivative of the high, in this case is 1, minus the high times the derivative of the low. Well, this is where we're going to need the chain rule. We're going to times it by 1/3, keep the x squared plus 4, and then drop it. So that becomes negative 2/3. And then you times it by the derivative, which is 2x. All over low. So that's basically, it's just taking this and squaring it. So you're multiplying that by 2, so that's 2/3. All right, I'm going to clean this up what it looks like. All right, right now I've got x squared plus 4 to the 1/3. All right, this is, I've got an x and an x, which makes x squared. And then 2/3. So I'm going to say it's going to be 2x squared up top, the 3 down low with this x squared plus 4 to the 2/3. Now, that's kind of ugly. All right, think about it. If I want to get this out of the denominator, I need to multiply it by 3 times x squared plus 4 to the 2/3, top and bottom. All right, so here we go. X squared. Okay, when I multiply this by 3 and I multiply it by this, there's going to be a 3 out in front. And then think about adding my exponents. What does that equal? 1. So it's just x squared plus 4. So that already worked out nicer. So minus, I'm still going to have the 2x squared, but when I multiply this, the denominator goes away, which is my goal. And then the bottom, that's going to be 3, and I just add the exponents. It's still going to say x squared plus 4 to the 4/3. All right, but it does look a little nicer overall. Okay, I want to simplify the top. This makes 3x squared plus 12 minus 2x squared. So the final answer will be y prime is going to be x squared plus 12 over 3 x squared plus 4 to the 4/3. Be able to simplify all the way down to something like this. All right, so within the chain rule, you may have to use quotient rule and then chain rule inside of it. So be very, very careful. Always continue to ask yourself, can I go dig a little deeper and go inside and find the derivative of that? All right, and let's look at one more. Number 9. And at any point you want to try this, feel free to pause it and stop and then see if you can get the same answer. Okay, to find the derivative, the first thing I see is the exponent. So I bring the exponent down, keep the inside the same, and then drop this by 1. So it's going to be to the first power. You don't need to do that. And then you've got to do times the derivative of the inside. I want you to notice again, we need the quotient rule right here. All right, so low, times the derivative of the high, minus, okay, high, times the derivative of the low is 2x, and then low. So that means square that. really what I need to do now, I need to simplify the top, okay? And I'm just gonna come up here and just do this. I'm gonna say 3x squared plus 9. Now be careful, I need to distribute this negative sign. So therefore that's gonna be negative 3x. Or actually, hold on, I'm multiplying it by the 2x. So that's gonna be negative 6x squared, okay, plus 2x. All right, so when I simplify that, that's gonna be negative 3x squared, okay, plus 2x plus 9, all over x squared plus 3 squared. Now, this can continue. I want you to notice I have an x squared plus 3 and I've got 2 of them here. That denominator can be x squared plus 3 cubed now. And now we can multiply this numerator and that numerator together and then times it all by 2. When you do that, and I want you to work it out yourself, you should know how to do that, you get a final answer like this. So when you're doing the chain rule, work your way from the outside in. Okay, start with any exponents that you have on the outside. Be careful of any trig and then the inside the trig, or in this case, you got inside the parentheses. Be careful, you may need to apply the product rule and the quotient rule at any time as well.